In today's video, I want to talk for a few minutes about the basics of of graphing a line. Okay, so we are often given a line in something called slope-intercept form. Okay, and this is where you have y is equal to mx plus b, and here m is what we call the slope, or this is the you could think of this as the rate that the line is increasing or decreasing. So how fast the line is increasing or decreasing. And we have b is something we call the y-intercept. Okay, and this b value is where the line is going to cross the y-axis. So if you set x equal to 0, that's going to cancel out this mx. And so this is where on the y-axis it's going to the line is going to intercept um, um, the y-axis. Okay, so knowing this information, let's go ahead and just dive into a couple of examples, and I can show you sort of how this works. So here's a really basic example. We have y equal to x plus 1. Okay, so here we have it's already written in slope intercept form. Okay, so here we have y equals x plus 1. Our slope is going to be 1. Okay, this is because it's 1 times x. You can really think of this as y equals 1x plus 1. Okay, so our slope is 1. Okay, and our y-intercept is also 1. Okay, so let's take a look at the y-intercept first. So if we want to graph this, what we do is we go to 1 on the y-axis. Okay, and that is our y-intercept. Okay, this is our y-axis. This is our x-axis. So it intercepts the y-axis at 1. And our slope is our rate of change. Okay, so we often think of slope in terms of rise over run. So 1 is equal to 1 over 1. Okay, and when we see some examples with fractions, this will make a little bit more sense. But for now, we can just think of 1 as 1 over 1. And here we have rise over run. Okay, so the idea here is the number on top is how far you rise. Okay, so you go up 1, and then run is how far you go to the left or to the right. Okay, positive numbers for rise means you go up. Negative numbers mean you go down. Positive numbers for run mean you go to the right. Negative numbers mean you go to the left. So in this case, we're going to go up 1 to the right 1, and that's where we're going to find our next point. You go up 1 to the right 1, up 1 to the right 1. Okay, and then once you've plotted a couple of points, you can draw a line through these points, and this is roughly what your line is going to look like. Okay, so that is how you would graph a basic line given slope-intercept form. Now, you might go on Alex and see that they want you to plot different points. I think that is a good idea. It's a good idea in the sense that it's a good way to check your work, but there are faster ways to do it than making charts every single time. Okay, so the way I like to do it is I like to use the method as described here, and then if you're not sure, you can go back and plot a couple of points individually and see if you've plotted it correctly. Okay, so let's say we wanted to see, well, what is this line going to be at the point x equals 2? Okay, so for x equals 2, we would have y equals 2 plus 1, or 3. So at x equals 2, we should have the value equal to 3. So we go 1, 2, 3. Yep, that's right. So we know if we maybe check a couple of more of these, we know that we've plotted the basic shape of this graph correctly. Okay, it is valid to graph a line by plotting its different points. That is totally acceptable. But I tend to find that's a very time-consuming way of approaching it. And there are faster ways to graph these lines. Okay, let's take a look at this one. Here we have y is equal to negative 2x minus 2. Okay, so our slope in this case is, let's actually change this example. I'll make it so that the numbers aren't the same. Let's do y equals 2x minus 3. Okay, so our slope here is going to be negative 2. That's our m value. Okay, so our slope is negative 2. And this can also be thought of as negative 2 over 1. Or you can also think of this as 2 over negative 1. These are all valid ways of interpreting this. And you'll see why I wrote these two different ways here in just a second. Okay, our y-intercept is going to be negative 3. And again, to see how we get that as our y-intercept, we can set x equal to 0. That's going to cancel out this negative 2x here, and we'll have y equal to negative 3. So at x equals 0, which is right here, we will have y is equal to negative 3. So that is our y-intercept. So our slope is negative 2. So that means if we look at it as negative 2 over 1, our rise is negative 2. So we're going to go down 2. And our run is 1. So we'll go to the right 1. All right? So we can do that again. We can go down 2 to the right 1. But we can also go, if we look here, we can go up 2 to the left 1. That's why it's important to recognize that negative 2 over 1 is equal to 2 over negative 1. Okay, we can go in this direction as well. All right, and once we've plotted a few of these points, we can just play a game of connect the dots. And we will have our line. And it'll look a little something like this. And again, if you want to, you can go back and you can plot points individually. You can say, well, okay, what if I checked for x equals 2? Let's see what we get. We'll have y equals, negative 2 times 2 minus 3. So we should have y equals negative 4 minus 3, or y equals negative 7. So we go over 2, 1, 2, 3, 4, 5, 6, 7. There we go. All right, so we're good. We've plotted this line correctly, at least at that point. If you want to check a couple of points, that's not a bad idea. Yeah, so it looks like we've plotted this one right. Now let's take a look at this one. We have y is equal to 1/3 x minus 4. Okay? Here, our slope is going to be 1/3. And our y-intercept is going to be negative 4. So at x equals 0, we can go down 4 to plot our y-intercept. And we have a slope of 1/3. Okay? So this is also equal to, hopefully we can see this, this is also equal to negative 1 over negative 3. Those negative signs will cancel, but again, we can see why this is important here in a second. So here, we can start from this point, and we can rise 1, and we can go to the right 3. All right, so rise over run. Up 1, to the right 3. Okay, or we can go down 1 to the left 3. That's where this comes in. We can go down 1 to the left 3. And now we have multiple points, and we can go ahead and draw a line connecting the dots. And now we have graphed this line. Okay, let's do one more example like this. Here we have y equals negative 2/5 x plus 1. All right. All right, so our slope here, our slope is going to be negative 2/5, or you can think of this as 2 over negative 5. And our y-intercept is going to be 1. So that means x equals 0, y is going to be equal to 1. And now we can do our rise over run for our slope. So we go down 2 to the right 5. Okay. Or we can go up 2 to the left 5. and we can connect our dots at that point. And that's roughly what your line is going to look like. Okay? There are a couple other types of lines. These are not necessarily written in slope-intercept form, but they are important lines to know how to graph as well. These are fairly simple, fairly straightforward, but I think it would be worth taking a look at. What if you're given something just like y is equal to 2? Okay? The way you should think of this is all points whose y value is 2. Okay? So you're going to have, so for example, you'll have the point 1, 2. You'll have the point 3, 2. You'll have the point 2, 2. You'll have the point -6, 2, etc. Right? You'll have like every point on the graph whose y value is 2. Okay? And so if you were to plot all of these points, what you're going to find is, let's plot a couple of these. We'll have 1, 2, we'll go over 1, up 2. We'll go over, looks like 3, 2, over 3, up 2, 2, 2. All right, we'll have -6, 2, 2, 4. I think that's -6 there. And what you're going to find is really what you're looking at here is a horizontal line, okay, at y equals 2, okay? So that's what that. Anytime you see a y equals a number, you're going to have just a horizontal line. Another way to think of this would be like saying we have. You can also think of this as y equals 0x plus 2. Okay, so your y-intercept is 2. Okay, right here. But you're not going up and you're not going down. You're not go you're and so therefore your line is not going to be increasing or decreasing. Okay, so it's going to be going directly across. Okay. All right, and another important type of line to look at is a vertical line. Okay, this is given by x equals some value. This is all points whose x value is 4. In this example, at least, x value is 4. So this will include 0, 4. Oh, sorry, no, other way around. Sorry, 4, 0, 4, 2, 4, -1, etc. Okay, you can plot as many of these points as you want, but for here we're going to go over 4. Okay, so for 4, 0, we're right here. We'll have 4, 2. We'll have 4, -1. So here we can see we have a vertical line at x equals 4. Okay, so that is how you would graph one of these lines. You can change the value up, x equals -2. It doesn't really matter. It's going to be just a vertical line starting at that point on the number line. Okay,